Hello. So, I have recently come to the realization that there is two kinds of code in the world. There is my code, and then there is everyone else's code. And while I can kind of live with my own code, it's not perfect, it has issues. I get by. Other people's code intimidates me. Here's a localization effort for this idea. When you're working with other people's code, you have to be careful because you never know what's going to happen. If you poke it, how it is going to react. And I've been kind of thinking, why is this? Why is there such a distinction between these two? And what I think it simply boils down to is that I understand my own code. Because I wrote it, hopefully I know what's in it. That's not quite as true with other people's code. I kind of have a vague idea of what it's doing, but it gets more vague very quickly if I try to figure it out. And why I think this is an interesting thing to think about is that we have very different ways to deal with problems depending on which side of this divide the problem seems to be. So if there's a problem in my code, I can use a process of reasoning to figure out what's going on. I can kind of step through the code to find a solution for the problem. I can't do that with code that I don't know. For that kind of code, I need to use a different kind of problem-solving toolkit. For me, that includes things like trying to come up with the Google search that explains what's going on, that will bring up the Stack Overflow pages where other people have explained it to me. And this can be effective. I think we all know that because we all have to do it from time to time. But there are issues with that. For me, one of the issues is that when I solve a problem in this way, I often come up with a solution that I'm not completely happy with always. Like, it might seem like it fixes the problem, but it's probably addressing the symptoms more than the root cause. It also might be the case that I do like 10 different things, and the combination seems to work, but I'm not sure what I actually did. But because it works, I just leave it. And some of that might be unnecessary or even harmful. So the solutions I come up with when doing this Stack Overflow-driven programming are suboptimal. And that's why I think it would make sense to try to maximize the surface area of code that I can reason about. And I kind of defined it as my code earlier, but I think it's important to understand that you can kind of take ownership of other people's code as well to know it well enough to be able to do this reasoning. How do I get rid of this thing? So I kind of was facing this question last year when I was starting my first Angular project. People were saying it's a big framework, it's difficult to understand, the documentation is terrible. So I was worried that it might become one of these things that has me spending my days on Stack Overflow for the next several months. I made a decision not to let that happen and started to really learn it from the inside out. That became the Build Your Own Angular project. That's a book project, and the premise of it is that since the code that you understand best is the code that you wrote, an effective technique for learning a framework is to write a version of it yourself. To gradually add the features to it, add the complexity to it, so that you actually build up a version of that framework, but then you throw it away because you use the byproduct actually that you get from the process, which is the mental model of how that framework works, what it includes and what it doesn't include and why it does what it does. And that's Build Your Own Angular. Today I kind of wanted to try to give you an idea of what I am talking about with this process and this idea. And that is to concentrate on a specific part of Angular, which is the Dependency Injection framework. I chose that part because it's interesting because it's controversial, right? When people criticize Angular, they often use the DI stuff as the reason they don't use it. So, for example, a couple of weeks ago, there was this big article by Rob Ashton, "You have ruined JavaScript." How many people actually saw that? Maybe a third, okay. But the whole point of the article was that the Angular DI framework is overcomplicated for the problem it solves, and no one should be using it, and it's basically ruining JavaScript. So that's what we're going to do today. So within the next few minutes, I hope to kind of build up a simplified version of the Angular injector. And if you are an Angular user, you might hopefully get a deepened understanding of what it's doing for you, if you don't have it already. And if you're decidedly not an Angular user, you'll probably, after this, be able to describe in great detail why you don't use it. So we have an example application here, which is in the space exploration domain. We've already been there today. We have a launch rocket function, which launches a rocket, which, look, no hands, which you can simulate by using the console. And then we have a constructor function called the big red button, which constructs objects that have a lid which you can open or close. And that's done by setting this flag in the object. And then you can press the button with another method. And when the lid is open, it will launch the rocket using that global function. And finally, we have our kind of main space exploration routine, which constructs one of those buttons, opens the lid, presses it, and closes the lid. So this is a kind of a simple application in which we're going to be working that logs things to the console. So how we might want to improve this is to make these components slightly more generic. So for example, this big red button can currently only be used to launch a rocket. There might be other uses for a big red button, so it might make sense to give the action, target action of that button to the constructor as an argument. And that way you can use it for anything. And you kind of shift the decision of what the button does to whoever constructs that button. And we could do a similar thing for the actual space program function. We can pull the button out of that function and make it the responsibility of the caller to decide which button is going to be used. So button comes in as an argument and over there, and we don't have to do it within the code anymore. So this is dependency injection, basically. We've pulled out things from those functions that they were previously constructing or looking up, and we push them in instead. And in the process, we've made those functions more generic, more reusable, in more contexts. And if your application is as small as this one, god damn it, is as small as this one, you won't need a dependency injection framework to kind of do the dependency injection. But if you try to imagine, there might be programs larger than this one, like 100 times larger, where you would maybe want a dependency injection framework to help you, such as the one in Angular. So we're going to make one of those. With Angular, you get this thing called an injector, which is usually kind of baked into the structure of the application, but you can also use it as a standalone object. To the injector, you can register like components, things that it knows about. So you can let it know that there is something called a button, which is this value here. The simplest way to do that is to use this function called constant, which just lets it know that this exists. Then you can ask the injector to inject those things into where they might be needed. So here we're asking the injector to call this space program function and also supply it with any dependencies that it might have. So as we call the function, we don't at that point need to know what it needs. It's because we've wired that up elsewhere. So to make this simple injector, we'll introduce some framework code on the top of the file. There's a top-level function called create injector, which returns an object that has those constant and invoke methods. Constant takes a key and a value, and invoke takes a function. So what we need to do is we need to kind of register things as someone calls constant and then look them up when someone calls invoke. The registration we can do in a local cache object. Simply put things in there. And then we need to look things up. And here comes the tricky part. How do we kind of know what a function needs when we need to call it? What do we need to supply to it as arguments? In Angular, there are several ways to do this. You can kind of explicitly annotate a function to say that these are its dependencies. But maybe the most interesting way to do it is to kind of, at runtime, on the fly, look things up. So what we can do is every function in JavaScript has this method called toString, which returns the function's source code as a string. That source code includes the argument list of the function, which we can extract with a regular expression. So we can match that string, and the signature begins with the word function, followed by some white space, then maybe the function name, which we define as a bunch of characters other than the opening parenthesis. Then we can match the actual opening parenthesis, which begins the argument list. That we capture into a capturing group, and what we capture inside is everything that we see except the closing parenthesis. And then we close the group and match the closing parenthesis. And that gives us this match result where the second item is the argument list of the function. And to get the actual arguments from that, we just split it at the comma to get an array of argument names. Now, this is one of those things that people probably criticize for a good reason, because it's totally non-obvious. It breaks when you minify your code. It's weird. And I should say that this is going away. So in Angular 1.3, they are introducing this so-called strict mode that actually throws exceptions when you try to use this style of dependency injection. And Angular 2 will do away with it completely. But right now, it's the most typical way you do it, because it's the most straightforward way from a user's perspective, and it's what all the examples use. So that's what we are using now. So we're going to now pull this code into our framework. As we do the invocation, we can look up the arguments. We will first get the arguments string, then split it at the comma, and map that so that all white space from those argument names is removed with the replace operation, and that gives us an array of the argument names. Then we can just do the lookup from the dependencies that have been registered by mapping that into things from the cache. And then all we need to do is apply the function to those arguments. Let's see where we were. Here. So now we have this kind of simple injector working. There is more we can use the injector for, though. We still have to kind of manually create this dependency between the big red button and the launch rocket, because we're kind of constructing it here and giving the end result to the injector. We can delegate more to the injector if we use a method called factory instead of a constant. So if we put in the button as a factory, we'll give it a function that returns the button. So this is the big difference between constant and factory. With factory, you don't give it the concrete dependency, you give it the function that produces the dependency. Right now, these two ways of doing it are functionally equivalent. But when it gets interesting is when there is something registered to the injector that you might need for the button, such as the target. We can inject the factory with that thing. And this way we can break the dependency between the big red button and its target, the launch rocket function, because we no longer need to know what the button does as we constructed it. It's been wired up elsewhere in our source code. And how we make this work is we make a new method in Injector, which takes a key and a factory function. Now we can't just put the factory function in the cache because the cache is for instances and not these factories. But we also can't call the factory yet because it's fairly important that for application programmers there is a load order independence so that I got lost here. Load order independence so that people don't need to provide the dependencies in the order in which they actually use them. Because we are basically remembering what has been registered and looking it up on the fly. So what we'll do instead is we'll keep that factory around. We have two caches now, one for providers and one for instances. The constant goes into the instance cache and the factory goes into the provider cache. And then as we do the dependency lookup, we need to look at both of those caches. Primarily, we'll look at the instance cache. If it has the dependency we're looking for, we can just use that and return it. But if there is nothing in the instance cache, we'll secondarily look in the provider cache to see if there's something there that we can use. And if there is, that's going to be the provider or the factory function. And to then get the concrete instance from that, we have to call it, and we can do that by recursively calling invoke, because that's also a dependency injected function which can be invoked just like the one we are currently in. So this is how you get transitive dependencies. And then we can just return that. And crucially also, since everything in Angular dependency injection is singleton, we'll put that in the instance cache so that the next time someone needs the same dependency, we can return the instance and we will never call that factory function again. So, how much time do I have left? A couple of minutes. I still probably have time for the last thing. Well, actually I don't, so I'll just go quickly through this. The next thing I would have shown is that you can build on the factory to actually make something called a service, which means that you can actually give it this big red button constructor directly without having to wrap it into a factory function. And then it would call new on it and supply the new object and set up the prototype chain and everything. But we can discuss that in the discussion track if you're interested. But this is kind of the idea of build your own Angular, and this is also the idea of this style of learning that I find very useful. It's a very time-consuming way to learn something, to break it up and then build it up again. But when you have done that, you really do understand what the tool that you are using. And for something like Angular that's going to probably stay around for a while, in my projects and in general, I think it's a good idea to do that. But yeah, we can continue on the discussion track. Thank you.